Okay. Okay, we're ready to go. Hello, everybody. Okay, it works fine. Technology check. Works good. Welcome to our expert panel on embedded vision at the Embedded World 2024. We are proud to present the topic embedded vision, the impact of generative AI, and have a really nice audience sitting here. There are some chairs left in the front, so please come to the front, some empty chairs. I think it's more interesting here in the front. You can be more or less live on stage with us here. Yeah. Thanks for my guests here on the stage. I think that will be an interesting hour that we can talk and discuss. For you, it's possible to ask questions. So please raise your hand, give us a signal and say, okay, I have a very important question that will be really interesting for the audience to be answered by us. I hope we can answer this question. But as far as I know you, we can give a good answer. So to start with, I would like to present my guests here on the stage. I would like to begin with Olaf Munkelt. Maybe you can tell us in a short overview who you are and what you're doing.
Yes, of course. Thank you very much, Oliver, for this introduction. My name is Olaf Munkelt. I'm co-founder of MVTech Software, a company who makes standard machine vision software for all kinds of different applications. And our idea about embedded vision is that we want to provide standard software also on a clumsy embedded vision system, make it easy to use, and thus also enlarge the customer base of embedded vision hardware.
Thank you, Olaf. So you should remember who is who and what is the topic of every one of us. So if you like to ask questions, you can point out whom you would like to ask this question. So my next guest is Chen. Please tell us about you and what you're doing.
Thank you, Oliver. My name is Chen Su. I lead product marketing for NVIDIA Embedded AI and Robotics platform. I based out of Silicon Valley, and just being glad to come here and talk to everyone and share our insight in generative AI and the future application. And specifically, we see it's a huge year for us because we see a lot of great demo here, kind of showcasing some interesting part of those. And today I would like to share more with the fellow experts here together and discover more use cases to you guys.
Thank you, Chen. And now we come to Martin. Please take the microphone.
Yeah, my name is Martin Klenke. I'm working at Teledyne Imaging, a cross-section provider for hardware and software in the vision field, including embedded vision stuff. And I'm in charge of running the integration group. That means I'm taking all the components which we have, putting together, and we solve specific solution for our customers who have not an interest to just buy components or something like that there. I'm very interested in generative AI, which takes a very big and upcoming role in our use cases in the last couple of years, I would say.
Thank you, Martin. And now last but not least, Gareth.
Hi, everybody. So I'm Gareth, marketing manager for Prophecy. Prophecy make event sensors. So we do a kind of novel sensing technology, which is basically ideally suited to AI machine learning applications. And so I'm based out of Grenoble and happy to be here with you. So I'm the sensor guy, a bit outside.
Thank you, Gareth. So about me, I'm Oliver Helzle. I'm CEO of the company HEMA Electronics here in Germany. And we specialize on hardware design using FPGAs for embedded vision. So you get a rough idea of our specialty software, hardware, sensors. So we like to have a guest here on the podium to have the different points of view on this topic. And I think that will be the interesting point that we have. What we want to do in the next couple of minutes, we want to present a discussion about the topic impact of generative AI. and we want to focus and give you an overview of the latest developments, trends, and what this topic means regarding applications, regarding software and hardware. So, as you all probably know, it's a mixture. You need the sensors, you need hardware, you need software, you need a clever architecture to build at the end the quality that these systems should provide for you as a consumer or applicant or developer of these topics. So to start with, to give you an overview what we mean by generative AI, I would like to ask Jen to give a rough definition of generative AI regarding our talk. I think that the universe is much larger than this, but for us it should be the topic for today.
Yeah, thanks, Oliver. I think the quick one-sentence description about generative AI is it is a computer model that can take the past or existing content that could be, text, video, imagery, 3D input, or even, I would say, protein information, any type of format, to generate a new insight, a new type of content. And the new type of content can also be any type of content, such as text and image and video. So it's just really, really interesting because in the past, compared to the traditional AI, it's only do one thing, which could be classification or detection, but generative AI is very generalizable, which is can do anything based on human prompt. So that's really the beauty of the technology.
Okay, thank you, Jen. And to start with, our first topic is the embedded vision. And I would like to ask my guests about which new application examples will you present today or in a couple of weeks or months to come by yourself or by your customers. What is new and what is in the context of our topic new to your example? I would like to start with you, Gareth.
Okay, fine. So we have some existing customer traction in things like fall cameras, again with lots of machine learning. And the reason they're interested really in our event sensing technology is that with an event sensor, you only see contrast differences. So you only get basically anything that moves, you only see a silhouette. So you cannot really do detailed face detection, cannot do room. So the room itself is basically invisible to the camera. And of course, you can do all this post-processing with a conventional camera, but it's really done at pixel level in the event sensor. So for these privacy concerns, this is an area where we see a lot of traction for event sensors. There are many other in AR, VR. Okay, and again, what they're really exploiting is the low power aspect of the event sensing technology.
Mm-hmm. Okay, so I would like to pass over to Martin.
Yeah, we use AI in a variety of different applications already. Just anything what is coming up is object recognition or filtering purposes or denoising. That's very well known, I think, in the industry. However, more and more important gets generative AI things in terms of predictive maintenance and prediction of, I would say, streams of goods or cars or anything what is moving around fast in a quite uncontrolled manner. So observation, surveillance is definitely a topic what we would like to see coming up very quickly. I personally also have the vision that we think we can do a lot of things in the automation, in the control of logistics, and also in the control of robotics and handling systems, always in the sense of learning in terms of prediction, what happened next, so you can get a first guess. Mm-hmm. However, many of our customers at the end needs to have a control. Is this really happening? What is it being predicted? That's a challenge what we see in the future.
Mm-hmm. Okay, thank you.
Yeah, I think that if we go back a little bit and have a look what is the current situation, the status quo, I think that we still see many rule-based systems implemented in vision sensors for very good reasons. and deep learning AI is a technology which is for, say, many, many years available. But just recently, we saw the first vision sensors which actually use the technology. Because on an embedded system, we always have the problem of power, of heat. We have the problem of low performance compared to a PC system. And this makes it hard to really implement a fairly good solution for which uses deep learning technology. And today what we see is on the vision sensor side, we see classification implemented in deep learning, but we don't see semantic segmentation. We don't see anomaly detection for very good reason. And why? Because you cannot train or retrain your model on an embedded vision device. It simply has not the power you need to do it. So we have the big objective, we want to get better, and we know a path how we can go there. But on the other side, we are tight with the performance, so to speak.
Yeah. Absolutely, that will be one of the topics we're going deeper into. Yeah. So, Jen?
In my perspective, NVIDIA, because it's a platform company, we enable a lot of other companies to be successful. We have seen, I think, primarily generative AI can bring so much difference in terms of, contextual understanding and how it can improve the interaction with the video or text or even the machine's movement, right, is captured. So if you want to break it down, for example, for vision AI area, we have seen application that can do video summarization and video search, meaning you can get the video input and you can summarize the entire thing is see. For example, if you have something put traffic interception, it can understand what's going on in that traffic interceptor, understand if there's an incident happens, and summarize incident report at the edge. So that's very interesting application, and you can imagine the similar video summarization can be applied into industrial and other area. And the second thing that we have seen in the robotics area, as you all mentioned, the control of robots is moving from the traditional rule-based model to AI-based robots and slowly migrate to a foundational robotics model. Kind of, you have one model not just doing one thing. That foundational model can do many things. It even can mimic the behavior of human and follow you, which is the capability that we never seen in the past. Okay. Last but not least, deploying on embedded system, we also see large language model that enable a ChatGPT-like experiences, but more tailored to certain industry. It works almost like a knowledge co-pilot. Imagine you are working in a factory machinery, you can put the manual information inside in that model, and the worker can access to that information and use prompt to ask question, how can I repair this? What is the procedure for maintenance? So on and so forth, which is superpower, right? Because we never seen that in the past, and usually it's depend on the worker's knowledge rather than suggestion coming from a computer AI model. So those are the future application, I think.
Yeah, I totally agree. The control of an AI system is of superior importance for us. So we have many use cases where it's very helpful to have an AI system, especially a generative AI system is helpful in making kind of a pre-decision model, but the final control still has to be done, especially in safety and security issues, or if you really have to have a very high yield. So I think the combination of rule-based, manual, and also AI makes the trick at itself. It's just another tool what helps. However, coming back to what Olaf said, embedded, yeah, well, we get a more and more powerful hardware, that's good, also in embedded. Yep. But I see a big trend also for the lower and lower performance hardware. And I think one lead, maybe also what NVIDIA follows up there, is to do dedicated AI processor types which are low power, low performance, and I think that's a key for the next couple of years for embedded applications.
Okay, thank you so far. So what we want to look at in the next couple of minutes. So in 12 months, there is an embedded world show again. So we don't want to look for the next couple of years, 5 to 10 years. So there's a lot of speculations about what's happening in the future. You've seen all the movies, what could be done or not. We want to focus on 12 months because in 12 months we sit again here and can update. So we want to go to the point that what you already pointed out in parts, that where do we stand today? So today meaning what can we see here and what will happen in the next 12 months, so in the near future. So what have you available for your projects in the near future? So some of the points you already told. Maybe who wants to go a little bit deeper into the state of the art today?
Yeah, I can give a quick comment on it. I think for AR, VR, for example, eye tracking, a lot of the classic applications are foveated rendering, for example. But we're seeing much more interesting uses for that, particularly with generative AI. So, for example, we have a customer partner who is developing gaze tracking, okay? So basically, you have outward cameras which are looking at the world, and in the eyeglasses, you have inward facing cameras based on our event sensors, and we are able to detect with 1 degree of accuracy the gaze direction. And so then you could say to like ChatGPT or something, or Gaze GPT, maybe it'll be called, what am I looking at? And then, instead of the whole world, it'll tell you exactly what you're looking at and describe it. And this is working very well, actually, and extremely impressive.
Okay. Another opinion? Yes, Chad?
So I think the state of art today, as we've seen on the show floor, there are already large language model deployment and also visual language model that can prove today working very well in the embedded devices. Of course, it requires some high-level processing power, but over time, and of course, the memory is also important for large language model deployment. But over time, you will see there will be more smaller size model developed that can fit into smaller devices, I would say. But looking forward in next 5 years, I think the challenge is not just because those models are so new to us and we don't know how to use it, but more importantly is building application takes much, much longer time. If you think about today's AI, like how many projects can be landed, most of the time is hard because application development takes years. It's really require a modern cloud-native architecture in terms of their software stack to make it faster to build it. So I think all the companies should work together to adapt to cloud-native architecture like microservices and bridge that with the new AI models and make it faster to bring generative AI to the edge and to the customer and create value for them. And I think in the next 3 to 5 years, you will see a lot more companies doing so.
So how could we balance the need on hardware and software? Software takes time, as you told. Hardware, it's quite good, but software is developing that fast, so we will never be fast enough with the hardware, especially what Olaf told us, that when we are at the edge, embedded at the edge, we don't have data center on-premise to develop our models and to train them. So how could this be done and how could this be balanced?
I totally agree with you. We have seen many customers in the past struggled about building their application. Sure. So for NVIDIA, we create some pre-built microservices for customers so they can directly deploy on our platform, and also pre-trained foundational model that they can download, which has already been optimized. So they don't need to go from zero. They can go from a certain level and fine-tune their model using the workflow that make it adapt to reality. But we're also trying to help the whole ecosystem to embrace this approach, because only if we all taking a modern approach to do it is make it easier for the whole ecosystem to adapt to it. Even for, let's say, my fellow here doing cameras, sensor, how to discover them, make it easy to figure out the foundation, and then building the model will be faster. Because it's not just about one model, it's the end-to-end application. You have to take care of all the pieces. So I think that's really important.
Yeah. Olaf, Martin?
Yeah, well, okay, thank you. No, for us it's very clear. The biggest cobblestone for integration, any AI solution, especially on a low performance system, is having a helper who helps you to receive trained models, pre-trained models for a specific application. I think that's absolutely true. And that's definitely the focus for our software development in AI in the future. We already have systems in the market which can be trained very manually and helpfully, and that is very well received in the market. That's I would say level 0 in the moment. However, we are focusing our hardware development in the same way to very powerful, very low performance systems with the latest stage of processing units. And we believe that there is a big market coming up in the multi-vision system. That means combining different sensors. That means optical sensors in the first sense, but not only, to create kind of a framework for our customers. And this enabled us to work on a platform strategy, and AI is definitely a big part on that. But it's a challenge for the AI software producer to cover all the different aspects in one shot, and I think that's definitely a case-by-case decision, and we have to work closely together.
Yeah, several topics. Maybe number one, software can't change the hardware, but the hardware can change the software. So, which means that we have to live with the hardware which we get, so to speak. As a software maker, we have to see how we can get our software on this hardware and make it as efficient as possible for our customers. And you talked about the ecosystem at NVIDIA. I think this is a great point, because that relieves people from the pain to do all the interfaces by themselves. I'm sorry to say, but there is a world outside which does not use NVIDIA. So, and all these guys, they are struggling with the interfaces. And we've been discussing with companies who build AI accelerators, which are now also part of, say, PC systems or embedded systems. And just to give you an idea, this took about, I would say, in my words, my experience, 4 years or so before they are really available now. And now you see them, I would not say everywhere, but you see quite a bunch of accelerators here on the show as well. So this is a compromise, so to speak, and you can leverage these low power consumption devices in order to set up a kind of economical embedded vision system. And the tool chain is kind of okay, I would say. So you still need a lot of experience in order to adopt these tool chains in your own application.
Okay, thank you. So you see, we have a lot of challenges. Yeah, let's call it ecosystem. I think we mean everybody from sensors, hardware, software to applications, and at the edge and at our data centers. So we need all of them. So we need all these skills. And everyone struggles at their point, and especially I think at the interfaces, when we combine hardware and software, we combine sensors, when we want to put our models at the edge and not train them anymore and see how they perform. So let's wrap it up at this point. We need all of these skills, and this, the results will be best if we get that right, connect the right people, and talk about the thinking and how it works, and build the systems up one after the other. So our next topic is the impact of generative AI. So what impact do these generative AI models have on embedded vision applications already today? And the second point is, and in the future. So where are we now? And what will come next? We said, okay, 12 months. So let's have an outlook. What do we solve in April, and what maybe we do at Christmas? So to have these points of view, I would like Gareth to begin with.
Okay. Well, I already mentioned the gaze tracking application, for example. This is well, we're going to see a lot more of this kind of human interaction with where we basically it's not a text application any longer, but it has much more comfortable experience for users and much more context related as well. So I mean, gaze tracking is one example, but it can be gesture recognition and all sorts of other things in neat ways. So you don't have to press buttons or anything, basically.
So we are come away from pressing buttons, so we can interact with gestures, with our point of view that we set. So the machine, the application, can see what we want to do, and not just type it on the keyboard anymore.
Exactly. So it'll be much more comfortable experience for everybody. It requires things like smart glasses, for example. So there still has to be a camera somewhere to do all this. But yeah, but it's definitely going the right way.
Okay. Thank you. So Olaf, would you like to continue? And then we go through.
Maybe I want to go one step back and think about generative AI. We heard the definition. Very good. I would like to highlight the word generative. So this means it generates something. If we talk about embedded vision, then usually you want to extract something from an image, and you don't want to generate something. So this is already the pointer, so to speak, in order to say, so where does this deliver better results for inspection, better results for classification? And this question is not as easy to answer as it is C's. So if you look at deep learning, of the old deep learning, say it this way, we already had the problem that in many manufacturing processes, you have millions of good images, but only one which is bad. So how do you derive what are the characteristics of this bad image in order to identify the next one in advance, so to speak? This is not so easy. Then people said, oh, no problem, no problem. I generate you defects in the image, some artificial defects. And then we train our model with this artificial defects, and everything will be all right. There have been companies founded just around this area, just to generate good defect images, so to speak. The problem is that you find applications where they really work very well, but there's no way to generalize this, unfortunately. So that means you have to start from scratch in every application to look how you generate good artificial virtual defect images. And now you can say we have generative AI. They can generate also images. Yes, they can. But up to now, we have no good experience, at least in our company, that the defects which are generated really represent artifacts, real-world defects, which we see from customers. So there is a gap between what the promise is of the generative AI regarding images and defect images and what the real world delivers as defect image. And that makes it a little hard to say, yes, we want to use generative AI. Maybe you see me in 5 years standing here. Yes, we have been using generative AI. But today, I'm really struggling in believing that this adds so much benefit that our customers are happy with it. And at the end of the day, our customers have to be happy with them.
Okay, thank you. So, Martin?
Yeah, this exactly describes the difficulties of in sufficiently wrong samples, right? So what is sufficiently, and that's really an unsolved problem. This is the same for us. I think for us in the next 12 months or something like that I don't know, 12 months, maybe 24 months, I think we will more concentrate on once the data are properly extracted, like reading the sensor out and put it in the memory somewhere, then we have all the data what to do with it, right? So that is very helpful, and then it is very helpful to have generative AI solutions, as I said before, for predictive maintenance or for predictive teaching of robots or something like that there, right? So we once have the data in a more or less old-fashioned way, extracted, maybe supported by classic AI extraction things, helpful, depends on the subject, and then using the generative nature of that software technology, of this learning technology, to create a data set for our customers, what they really need at the end. So apart from the vision processing, apart from the machine vision learning things, we set atop a generative AI layer for solving specific tasks, mostly very specific tasks. So we get around on this wrong sample thing there. But you're right.
Okay.
So, sorry, one maybe other complication to add to that is that, you know, any model has to work in all kind of lighting environments. So, you know, when you've got one data set you're happy with, try it at night and then, you know, nothing works anymore. So easier model generalization is definitely something that's needed. And again, I'm going to blow the event sensing trumpet once more. Basically, the image output of an event sensor doesn't change whether it's day or night. Some performance metrics may change in terms of latency and this kind of thing, but it makes it much easier to have a general model, basically, using event sensing. So.
Okay. Chen?
What I want to say is, I think we just discussed two kind of part of the equation, where the first part, you mentioned on the model training side, how generative AI can be useful, where, yes, without, you know, sometimes we can get real images, like defect images, sometimes we couldn't. Then you can use a simulation to generate synthetic data. Those data could come from a prompt, and that is doable today. However, it might not be perfect, so it's always a balanced approach in the training stage to take both real data and synthetic generated data to solve the problem. And in terms of the inferencing side, which once you have a model that is powerful enough, that is a foundational model, and deploy at the edge, I think the biggest advancement we will see is that it's very generalizable, because the model being trained by not just a certain object, it's being trained by millions, trillions, tons of the data on the internet already. Meaning it can do something called zero-shot inference. It might not train for a glass, but the model can detect a glass. The moment you want to switch it to detect people, it can also detect people. And I think that will be something quite interesting, because we often see in the field where customers have a request coming back to us, oh, I realize I want to evolve my model to be able to do something new. And the traditional approach is you need to retrain your whole model to do so. But now with the foundational model, you might be able to skip that step, where the foundational model would be able to handle various of situations. I think that's a very interesting aspect.
The underlying technology, the large language models, they provide properly a better foundation. Yeah, I would agree. And this is also what can be used today in terms of they probably help you to make a support bot or something like that, or explain bot, which simply explains the product. So the topic of documenting, say, a large product becomes very easy, because you feed this old existing documentation into the large language model in very basic terms, and then you are able, without retraining, to use that. So this is an advantage. This is great. On the other side, the existing deep learning approaches, they can be extended by something like continuous learning or something like that. So this is then a technology, so you can overcome the limits on that end as well. So, and for me, it's a little bit an open race. Where do we get the most out of it? Because that's what I'm interested in, so to speak.
So it really gets into what do we get out of it. So One point is the usability and the abilities that, or the chances that these models give us to create new applications, and especially user-friendly applications, because when nobody can use it, we had a great idea, but we hadn't made it usable, and the application will fail at the end. So what do the engineers and the people that work on these applications can get with these generative AI models to improve usability and build better systems?
Yeah, that's an old task, especially in the field of smart cameras and smart systems. How can I get a web interface or a user interface, an HMI and human-machine interface, what is exactly showing me the next step and nothing more? So I do not get an engineering screen with 100,000 knobs and rulers and whatever. No, I think generative AI should be possible. It's not ours, but maybe a question to the software guys here, right? To present the worker intuitively the next important step without being programmed. That means there's a guy standing on the conveyor and is putting cans on, or maybe a robot or whatever, and somehow something is failing. I don't know why, because it's an engine broken or whatever. Somehow it's failing. And then the screen, where the operator is running this, needs to be interactively be different than before. And that has to be done because of the generative nature of the sequence of the parts, and then something is failing. So it's a self-developing and a self-proposing system, if you say so. And for machine interface, human-machine interface, and also for data collection, everything what comes behind that, I think that's a big idea for a generative AI model. Right?
I want to add on to Martin's point, where you do see those models today can do self-evolving by taking a specific workflow called a retrieval augmented generation workflow, where you have one large language model that can access to a database that's keep evolving. And the database always have the latest and greatest data. So without changing your model, the whole output of this system can be smarter over time, and which we are seeing enterprise customers have taken this approach in the cloud, because every enterprise customer wants the model to access to their own data to create their own enterprise insight. And in terms of the machine vision or embedded system, that means what exactly you talk about. If someone deploy Gen AI for industrial production line, the database should update always with the latest production data, the menu of the machine, how to fix it, repair it, and that in the future can be able to keep evolving and always give you the best suggestion, actionable suggestion for the worker. And the worker can prompt and ask questions to the system and get answer directly. It should be as easy as that.
Let me add, I like that, good idea, yeah, but it's getting more and more complicated the more different sensors you have. Yeah, so you have a vision sensor, and you have a temperature sensor, and you maybe have a time of flight or 3D or whatever sensor, and some of them are reporting something is wrong. Please, worker, help me, right? And that's a big challenge for embedded systems, because you need to have intelligence in each one of the sensors and an intelligence in the framework where you do this. So at the end, we come to bigger hardware frameworks, which is supporting then a generative AI software network. So it's more than just a sensor, right?
But that brings us to our next topic regarding hardware. Yeah. We have hardware, software. We already discussed that. And what does the hardware role play today? We talked a little bit. We said, okay, there are some restrictions, there are challenges. I would like to go into more in this topic of regarding hardware. Is it getting less important because we have it, or do we get bigger problems because we have more variety interfaces and stuff? So what do you think? Yeah. Chen, would you like to start?
Yeah, I can give you my own observation on this because we have been testing different models on edge devices. We realize that the new generative AI model usually have trillions of parameters in the model itself, it's transformer-based model, compared to the traditional CNN-based model, it's only millions of parameters, which does require more processing capability. And more than that, I think another issue is when those models start to run, it's not detecting immediately. There's a process called pre-field, meaning it's first have to understand the context. And that process takes a lot of memory. So that means when you think about the traditional CNN model side map with a certain memory, now the generative AI model needs to map with a much larger memory because of that workflow and how it's being designed. So I do see today the performance at the edge kind of needs to evolve, and that's why you see more and more silicon processor company are keep improving the processing power, but at the same time, making it efficient is a challenge. How you can make it low power budget to help embedded system, that's very hard. So I think that is what I see as a thing. Maybe there will be a heterogeneous solution in the future where GPU, ASIC, and something gonna combine together to solve it. I think that could be the next step. I'm just giving a guess.
Well, I think, we are a cross-section provider. We're starting from chips and up to the solution, right? Yeah. There's a big trend in the sensor, in the imager field to do more and more performance directly in the sensor. And that's a super low power way to put more intelligence and especially more processing power inside of the first chain link, what's going on. And that is very helpful for embedded systems. And this is something you can maybe link through the whole process. I think Gareth can also tell stories about that in his life.
Yeah, definitely. The one of the big problems is how do you reduce latency when you're getting bigger sensors, bigger resolutions, more complex models to run. And I think the only solution is to really look at right at the source of the sensing technology. So, a new form of technology like event sensors, for example, this inherently reduces the data bandwidth considerably, about 10 or 100 times less for a given scene. And of course, the latency is in tens of microseconds. So it's really well designed for meeting this match of reducing the data and reducing the power. So we're starting to see much more traction in machine learning applications, in fact, because of that reason.
So you would tell the audience to look at the architecture. Where do we have the data? Where do we process it to handle the performance and power? Or is another, you shake your head, there is some more to this? Please explain.
In our experience, it's all about interfaces and protocols and standards. That means nobody really cares who is doing what on the sensor level, in the pixel level, on the AC-DC converters or whatever. Okay. That's not important. Important is how is the standard and how can I integrate that beast at the end, right? So the question is, how deep do you want to go if you want to sort tomatoes? So the question is helpful if you have an attitude to this, to understand every bit and byte on your system. There are companies doing that, absolutely. But I think the majority of requests is having an easy, simple, convenient system, what is exactly doing what you want, and maybe a little bit more. So the translation of the customer and the client demand into software and hardware is something what a vendor has to do, a manufacturer has to do. And yes, and to be interoperability terms, standards is all, right? Interfaces are all. So everybody should be able to integrate a sensor of someone else if that is better suited or less power consumption or a specific software runs in it or whatever, right? So the architecture itself does not play a big role, I think, in the market. It's more the usability of it.
The usability and the standards and the integration, the ease of integration. Yeah. Olaf?
Yeah, one more comment on the technical side. 6 years ago or so, we were also hesitating to use deep learning models because they are so big, and then people found out that, oh, actually you can squeeze them, and they still deliver, say, good enough accuracy for what you want to do. And I still believe we don't have reached the end in terms of what can we do on the large language models. We don't understand these models so well that we have an idea at this point in time where we can screw on one end in order to shrink this whole thing. And the idea about this, you make it smaller, is also to make it then available on an embedded hardware.
I want to echo the point, because even within the last 6 months, when we started to test the initial large language model till today, we see what it is. We have seen the model size become smaller, but can still deliver the similar accuracy and throughput that's being required. So I think the trend exactly what we have seen in the last few years when computer vision first came, CNN model first came, it was large, it was so hard to use, and eventually there's technology to compress them. And now with the generative AI model, there should be a way to make it a tailored version for certain tasks that you care most, and that would be able to deploy in much smaller edge devices. I think there definitely is a trend. But I think to begin with, at the same time, to experiment all the other possibility, you still require sort of processing power to begin with, because that's when you know what other use cases are possible. Because at the beginning, you are not focused on purely optimization. You focus on explore the right use cases, and then you optimize.
Just one sentence. Yeah? In 6 months, you did a marvelous progress. 6 months on sensor side is nothing, right? We talk about years. Yeah, that's it.
Okay, so on the one hand, of course, to play with these models, to test, to try to evaluate, we better use a data center, yeah. But then we have to transform it, shrink it down, like Olaf said, to a real edge hardware that is affordable, producible, and usable at the edge or in the application. Of course, it depends on the amount of units you need. Is it a special application, you need 5 of them, or is it a mainstream application and you need 5 million of them? That makes a clear difference and a big difference in how you balance the system and how many people use it and how you use it. Thank you so far. So we have some 12 minutes running on our time, and I would like to use the chance to have a break for your questions. Are there any questions that you would like to pass on to our guests?
Thanks. Hello. Very informative discussion there. I would have a question back to the model size. I think models like GPT-4 are terabytes of size right now. And for Gen AI, we need a foundational model. What do you think is a realistic minimum size of such a model that still delivers some performance that is usable? Back to your initial use case of vision system going through the factory and then summarizing, oh, I've seen there's a problem in that and that area.
Thank you so much for your question. From my experiences and what I have seen, at the beginning, we tested, for example, Llama 2 70B. It was really powerful. We tried to run it at the edge at 4 tokens per second. It's doable on our product, AGX Orin. But as we know, it's so large. It's very, very hard to generalize, because not everyone can afford that, and also it's not very easy to deploy. So eventually what we have seen in the last 6 months, I know 6 months is very short, but what we have seen is we find a model that we call it mini or small language model or mini visual language model that could be below 3 trillion parameters. Those models still very useful, and those models can fit into a much smaller form factor product which is under our Intron product line, and we already seeing it's working. So I would say in the future, the model could still continue to be smaller and more useful. I don't know the boundary yet, but I can only see what I have seen. Because in the beginning, when we experiment this, we didn't think it was possible, but now today it is possible. But just want to also add one thing is memory become more and more important in those use cases. We realize that the best memory size for running the smaller model, at least you have to get 8 GB memory. Otherwise, a little bit too hard. 4 GB, you don't have room for run any of your system applications. So that's what we discovered at this moment. Things could change in the future, and it could be evolve and make it even better.
Thank you. Thank you very much for your answer. Is there more to it?
Maybe a little bit more practical answer. It's also possible. We have, I think this is heavily depending on the use case again. Sorry, yeah. So we have an AI software running which is recognizing barcodes and DMC labels first of all. That's a tiny database. It's very small. You can run it totally in a smart camera. That's no problem at all. But we have another project running where we are tracking parts in automotive industry with lots of different features and a lot of different models and whatever. The database is huge. I don't have the idea how huge, and it's not even generative AI. That's a problem. So I think it depends what you want to do with that. How diverse is your sample at the end, and how delicate are the differences between the samples? And to put that then on top into the next level, into generative AI, that can boost your system dramatically. Right? So we need Chen for further reduction of the stuff, right?
Thank you very much. Is there another question? Yes, please.
Hello. Okay, thank you for sharing all those information. It's really helpful. So I got a question. So I think you guys talk about the language model, or the AI model is getting smaller and smaller in even 6 months. And also you guys talk about like from the hardware architecting perspective, running an efficient generative AI model does need more like memory capacities, higher compute powers. So my question is, as a customer, how do I make a smart decision at this moment so that when I choose the product here, how do I make sure I make a smarter decision so that I won't waste my money, so that I won't buy something like overkill and you tell me like after another 6 months there's a smaller model, you don't need that, or even after 6 months say, oh, you know what, you should buy a even more better product with a higher memory capacity.
Yeah, thank you for your question. So I think the very short answer is deflation. Deflation is a financial term, and it means that things are getting cheaper over time. Inflation is where things getting more expensive. This is what we all know from the last 3 years or so. So, and the same happens to your problem. If you decide to wait, you will get a better technology in 1 year, but you will also lose customers. So, in other words, if you have a need now, then please start now. And how to get started? From the application. So what do you want to generate as added value for your customers? And then you go back. And then you take what is available today in terms of you reduce the amount of, say, memory, you need this kind of performance, and that's it. And you can be 100% sure by the time you have made your decision that from 1 year now, you have a better technical solution. This is always the case. I'm so sorry to tell this.
I see another approach maybe that is usable. You see a lot of system on modules, modular architectures, main boards, carrier cards. So I think there's an option to think about creating a modular, scalable hardware for the beginning. And at one point, yes, you have to shrink it down to the final application, and then you're stuck in the moment. Yeah. And I know computers since kindergarten, and it was never fast enough. So it was, and if you wait, you get a better one, and if you wait longer, you get an even better one. So I think it's a timeless question, and it's a timeless problem. So like you said, jump into it, solve the problem, and then be flexible, and you can call it maybe agile or whatever, and be flexible and innovate at a high rate, because it will evolve, and even at some point there will be some things like a black swan coming around the corner, and you never guessed even that. So be fast, and use the time and learn and understand custom application. I think that's what you meant. Understand it. I think that's even more better approach than throwing hardware or software at one point. So I would like to come to our final question round here on the podium. So I guess all of you walked through the halls and looked at a different booth and saw what is hot and new this trade fair, this show in 2024. So I would like to ask my guests what they have seen so far for yesterday and today, and not only at your own booth, please, but what could be interesting for you as the audience. What topic is there? What surprised you? What is special? What is new? What is a good tip to see here today and tomorrow to work on for the next 12 months? Maybe that goes in the direction of the question, what should I use now? Yeah. So I would like to start with Garrett, and then we go to everyone here.
Okay, so I think I'm going to have to disappoint you a little bit, because I didn't get off the stand. This is the first opportunity I had for the last 2 days. So I'm just going to have to say, please come and visit the Prophecy booth. Okay.
Thank you. I think that's a great question. I see the things change a lot on the Edge AI space, where in the past, people demonstrate more on what is capable. Oh, I'm detecting people. I'm detecting Apple. I'm detecting things. Today, you see more application-oriented demo on the show floor, where they can showcasing a robot arm detecting, let's say, a grape and trying to cut it, and it's more close to the real-world use case. That's number one. And number two, I think is really new this year, is you do see many different vendors today showcasing generative AI. I see it's not just from NVIDIA partner, but also from the other company. It is a trend. It's coming. I think today in those demos, still the capability. Next year, probably going to see more applications.
Thank you.
Yeah, I think in the moment we have a little processor or CPU war, in a positive sense, sorry about that, coming up. I'm really impressed how short the product lifetimes are on the processor side, especially on the ARM-based processor, on the one hand. I've also seen that more and more AI dedicated systems, let me say so, are coming out of the world, not only from NVIDIA. So NVIDIA was definitely the strongest partner in the past, and I'm sure you will play a big role in the future, but there are more and more coming, more smaller companies, more suitable things, and less power consumption and all this. And on the lower end, I'm impressed that I've seen a lot of ESP32 applications. That means really small sensors with a very low power and a very low price, and doing just what they're made for. That's also very interesting for the embedded market. I think it's a big trend for me.
Yeah, I'm very pleased because this show, the embedded show, also has a section on embedded vision over there. There's an orange carpet. But the good news for you is you can go there and you can see a lot of exhibits regarding embedded vision. Yes. And you can also walk this hall, for example, because I have seen so many embedded vision applications and demos running on so many other booths that I think if I would count them, there are probably more applications than we show at the embedded vision side. This is one comment. That's what I noticed. Number two, if you walk in the show from the public transportation side over here, You see an advertisement, 200 billion processors have been used over the time span. He says ARM, I try to avoid it, but okay. So 280 million, a billion ARM processors. And this is only one manufacturer. There are more than this manufacturer here at the show. So this gives you an idea how important embedded is, how important embedded hardware is for our daily life. Because we use it already everywhere, and we will continue to use it everywhere. And this shows an excellent enabler for this technology.
Many, many thanks to you, my guests here up on the stage. Thanks to you for coming here and listening to our talk, our discussion. I hope we gave you some ideas, some topics, some inspiration. And of course, we didn't have the perfect answer to all of these topics, but I think that will be different for every one of you. And yes, there are a lot of stuff out there, and embedded vision is the perfect topic because most AI solutions depend on pictures, still pictures or moving pictures, so it's vision, and that's our topic. And of course, most people of you have this kind of topic regarding vision, images, and the topic of AI will be perfect combination on vision. So many thanks to this nice discussion and to all of you, and have a good day and stay at the show. And I think you have a good chance to take some knowledge, some information home and work on your project. So good luck on all of your projects and have a nice day. Thank you. Thank you.